take a look at something else called evaluation context. To understand and master DAX function, it is very much important to understand the evaluation context in DAX. What we will do is to start with, let us understand at a basic level of the concept, and then we'll proceed with taking a deep dive. So first of all, what is an evaluation context? So the environment in which a DAX formula is evaluated in, that is what evaluation context. In simple term, evaluation context gets applied before the DAX formula evaluates. This is very important. Okay. When we write a DAX functions or formula, it gets calculated within that environment. So what do you mean by environment? The cells surrounding, or the values surrounding the cell, and the whatever the filter that you apply it using a slicer, right? So to make this bit clear, the result obtained or returned by the DAX function can be different depending on the context. Do you agree with me or not? Even though when you use the same DAX formula, the DAX function, right, the result returned by or produced by the DAX function is can be different depending on the context. For example, I have a measure called total sales. The same measure, I used it in both these visuals. It's a matrix visual. Use the same measure. So in this measure, I have used the sum, the DAX function sum, to perform aggregation or summarization on the sales amount column. Fine. So I have used the same measure in these two different visuals, but I get different values for each row. If you see here, so the values for each row is different. But if you look at the total for these two visuals, it is same. The totals are same for these two visuals. But here, even within each visual, if you see, we can see that the different values computed for each row. Here also the same thing. So how is this possible? We have used the same measure in these two visuals. Okay. So in these two visuals, we did not specify anything in the DAX formula in relation to category or location. All we need is the total sales amount. For each row, we get different values, though the total sales value is same between the visuals, and the formula is also same. Though the formula is same, right? So the value is different because the DAX evaluates it against different subsets of data. You just think of the evaluation context of a formula surrounding area of the row where the DAX evaluates the formula. See, the total sales is this one, but that doesn't mean for each category the total sales is same, right? It is not same. So for each row, let's take this one, the beverages, the total sales, or for all the transactions that falls under the category beverages, the total sales amount is 400. It is not computing all the transactions total sales here, right? It did the sum of sales amount for all the transactions that belongs to beverages. The same is applicable here. The sum of the sales amount for all the transactions that belongs to Bangalore, it did this. But when I drop in the location name column here, it does the filtering automatically. Here also same thing. When I dropped in the category here along with the sales amount column in the matrix, it did the filtering automatically. So now the question is, for each row, It not so for, now the question is how it did the filtering for based on each category, how it computed the corresponding total sales amount, right? For beverages, what is the total sales amount? Dairy, what is the total sales amount? This is because of the evaluation context. The environment in which the DAX formula is evaluated. So in this case we have used the sorry, one second. So in this case the location dimension table filtered the fact sales table. So in this case the category dimension table filtered the sales table. So hope you understood why the value changes for why we are getting different values for different row. It is because of the environment, right? Because of the for the different context, obviously the row value changes. That is what that's what hope you understood with this example, right? What is evaluation context is all about. There are two types of evaluation context. One is the row context and the other one is the row context, other one is the filter context. So before evaluating the DAX formula, it applies the evaluation context in two parts. One is the row context and the filter context. Sometimes these two can coexist. Now let us start with understanding what is row context. So what is row context? Can someone tell me what is row context? What is your understanding around row context?
If we apply any function for filtering purpose to identify a row.
No, it is not filtering purpose, right? Row context, I'm talking about row context.
Okay.
So when will the row context be defined? Or when will the row context get created?
To specify a filter for identifying of a row.
No. When you define a calculated column, behind the scene DAX creates a row context automatically. Okay. Apart from this, when you use any iterating DAX function such as sumx or average x, right? So we can create a row context programmatically. So there are two ways of creating the row context. The one is automatic. Whenever you define a calculated column, the row context is defined. And whenever you use any iterating function, what do you mean by iterating function? The sum x, average x, min x, max x, the functions which ends with x are called your iterating function. Okay. So whenever you use this kind of iterating function, the row you can create row context programmatically. Okay. The row context is evaluated whenever an expression iterates over a table. For example, I just go to my so this is my Power BI desktop. So here what I do is, so this is my table. Look here, in this case what I do is, I'll just for you to demonstrate. Already I showed you several times, but anyhow we will do it one more time. So what I am going to do is, I just delete this row. Column, I just delete this column. So what we are going to do is, we are going to calculate the total sales, right? So in that case we are going to multiply the quantity by price in a new calculated column called total sales. I'm going to create a new column called total sales. Total sales is equivalent to, let's say I'm going to say quantity into list price. I defined an expression. Okay, it's already there. I give some other name here. Total sales 1. Done. So if you look at this expression, we have taken the product of the quantity by list price. So when you multiply these two, you are getting this. This is my total sales. This I call as a calculated column. So in this case, only the row by row calculation is done. So in other words, calculated columns, this is the calculated column. It evaluates the expression one row at a time down the entire column. So one row at a time down the entire column. So for these column, right, it does the row by row calculation using this. Let's know this is a formula. Using this formula, it did the row by row calculation. All right. So in simple term, the row context iterates the table, but it does not filter. You said filter, it is not filtering it. Row context does not filter. Please remember this. And also remember, the row context does not propagate through relationship automatically. Here the relationship is not coming into picture. So if you only when you use explicitly the related function or related table, the propagation happens, right? So manually you need to use the related or related table function. If you want to do a lookup on any dimension table to retrieve some value from another table to your present row, so in that case the propagation doesn't happen automatically. You need to manually enable it using the related or related table functions. So to summarize, in a calculated column, the calculation is done row by row. Row context is evaluated whenever an expression iterates over a table. Row context exists in a calculated column or iterating DAX function. Row context does not propagate through relationship automatically. So row context, what is the takeaway? Row context iterates the table, but it does not filter it. Please remember this, okay? The next one is the filter context. Filter context is used whenever a measure is calculated. Whenever you are using a measure, the filter context is used. So it is nothing but a set of filters applied to the data model. This is very much important. Don't forget this. Set of filters applied to the data model before evaluation of a DAX expression been started. For example, let's say you have a measure that sums the sales column in the sales table. Now let us suppose that you want to see what the total sales are by location. Right? So when you add a location dimension to the visual, the power by goes to the sales column and filters the column for each location and sums the total. So I'll just show you here. So I just go and create one measure. Okay, I'm done with creating a measure. So I just create a matrix. Just for our reference purpose, I'm going to use a chord visual. I just drag this here. It shows, or not this one. Total sales measure. Let me just remove this. 456.15k. So this is the total sales. Okay, all transactions put together, this is what the total sales we got it. I just show you one more time, simple calculation, sum of sales amount. Okay, we did it here, and when I drag and drop this in a matrix visual, it shows only this value, single value. So what I do is, I'm going to add a dimension with this measure. So you can use any dimension. In my case, I'm going to use a location dimension here. I just go and drop it here. So the moment, right, so when I dropped in the location dimension along with this measure, the Power BI, it goes to the sales column. It goes to the sales column and filters the columns for each location and sums the total. That is what is happening. It's so powerful, isn't it? If I tell you the total value, total sales value, and if I ask you to give me the breakdown by the location, right? If I wanted to see the sales by, if I want to see the breakdown of the sales by location, right? Just if you drag and drop the location dimension, it gives me for each location what is the total sales we made and what is the grand total. So what is happening? So how Power BI gives us the total for all the transactions that are made in Bangalore. How it computes the total sales for Bangalore. For all the transactions, what is the total sales in Chennai? For all the transactions that are, that were made in Delhi, what is the total sales? How it is possible? It is possible because of the relationship that we defined in the data model between the tables. Right, so look here, if you remove the relationship, it will not do the filtering. It is not going to do any filtering here, right? So it is not going to do. So it is all because so the filtering is applied on the at the model itself, right? So on the table level, it is doing that. So this is a one side, this is the many side. Look here, where is the location dimension here? So this is my location dimension. This is my location dimension. This is a fact table. This is a one side and many side. In this case, it does the filtering on the location, and then it filters the fact sales for each location, and for each set of transactions for each location, it does the sum or aggregation. It is because of the relationship. Now let us understand what other what is the what is the other purpose, what is the what is the other aspects of filter context. Filter context can be applied in a calculation. You can apply more than one filter context to determine a specific value. It can be applied using a visual, and also you can apply filter context using DAX functions such as calculate function. We'll discuss about calculate function later point. Even you can use the filter function also, using filter function, and also you can use slicer, filter, right? So now let us take a look at what are the different sources of filter that will be applied for a filter context. The row selection. Whenever you perform a row selection, it gets filtered. Okay, in the case of matrix, so this is a matrix. This is the, when I select a specific row, it does the filtering automatically, right? And column selection in matrix visual, based on row and column data fields, it does the filtering. See, in our case, it did the filtering. Did we do anything? All we did was just simply we specify the sum of sales amount. We did not specify anything regarding location. So what it did, right? So behind this, it did the filtering based on the row and column data fields. In this case, we have only one row, right? So we don't have any other column here. And also the filter selection, filter selection and slicer selection. In this case, we did not use any filter or slicer. So what are the different sources of filter, right? So wherein the filter context can be applied. So row selection, column selection, and matrix visual based on row and column data fields, and filter selection and slicer selection. These are the sources of filter, using which you can apply the filter context. Supposing now you tell me what is the initial filter context for this particular cell. The same example I have taken here. Okay, and if you look at this highlighted, if you look at the cell highlighted in red within this matrix, right, we can understand how this value is evaluated. So in this case, we must ask ourselves, what is the initial filter context for this particular cell? What is the initial filter context for this one? Can someone tell me? Any idea? So in this case, the highlighted value 7896 as a filter context for the row Hyderabad, the row which has the location Hyderabad. This is the filter context. In simple term, filter context is nothing but filtering. In select statement, we use where condition, isn't it? Where location is equivalent to Hyderabad. The same thing is applicable here also. Okay, you just think that way. So behind the scene, let's when you to answer to this question, what is the filter context for this particular cell, right? So behind the scene, the DAX, it performs 3 tasks. So all rows are filtered. Look at this one. Look at this one. So we are talking about the location. So in this case, we have the location name comes from location dimension. The sales amount comes from sales fact table. These two tables. Here we have this is one side and this is a many side. So when for example, here I highlighted the 7986, which is Hyderabad related sales. So in this case, there are 3 steps. It carries out 3 steps. So all rows are highlighted in the location table to display rows for Hyderabad. So in this case, we have only one record which has Hyderabad in it. It filters Hyderabad in this location dimension, and then it propagates this filter down to the down to this fact sales table from the one to many side. Step 2, and in step 3, now this sales table, the fact sales table, consists of the filtered records that are related to Hyderabad only. And then only the DAX formula gets evaluated. So what is our DAX formula? Sum of sales amount, and then only it applies the aggregation function on this thing. So in this case, we have highlighted this specific cell, right? So if you don't see, in this case, what happened? Right? So for each and every location, first it starts with Bangalore. First it filters Bangalore in this table, and then this filtered record gets propagated to this fact sales table. So in that case, you will have only the Bangalore related records. For all the Bangalore related transaction, it does the filtering in this table, and filtered records get propagated to this one, and then it applies the DAX calculation. So for in the case of Chennai, so 4,05,000, Bangalore 6,000. Right. This is how it works behind the scene. First, it evaluates the filter context. Anuradha, you were asking this question, right? So, whenever you use a DAX function, first the filter context will get evaluated, and then only the formula will get computed. Okay, now you tell me, what is the initial filter context for this cell? So you don't have to attend any prior session, just simple common sense. You tell me, now I explained everything, right? What is the initial filter context for this particular cell? The filter comes from Hyderabad,
Okay.
location name, and then diary, right? This is the category. These are the categories. So 1, 2, 3, 4, 5 categories are there. So for Hyderabad, in the dairy category, how much sales we made it. So this belongs to category dimension. This belongs to location dimension. This belongs to which table? Fact sales, right? So what happens is it applies the filter something like this. So in this case, what it does is you just imagine, right? See here different values are there. So this is my fact sales. The fact sales, and this is my fact sales. And here, let's say you have category and location name, right? So location dimension, it filters the location as in this case, in this case it filters the Hyderabad in the location dimension, and also simultaneously it filters the category table for dairy, and then these two filters will get propagated to your fact sales table, and then it did the aggregation. So this highlighted cell showing 5395 has a filter context for the location Hyderabad and the product category of dairy. So this is the initial filter context for this one. Now you tell me what is the initial filter context for this particular cell. Here I have a slicer here. Slicer is also visual, matrix is also visual. Now you tell me what is the initial filter context for this particular cell. In this case, the value 200 as a filter context for the location Bangalore and the product. See, this is the product name, okay? The product of ice cream, and the month is August, right? So you need to include this one also. So that is what is getting filtered at the model level. So the product name is ice cream, will get filtered in the product table, and then in the calendar table the slicer filters based on the month which you have chosen here, and then the location comes from the matrix, the Bangalore. So all these three filtered value it goes. It's something like select sum of sales amount from fact sales where product equal to ice cream and location equal to Bangalore and product equal to ice cream. In a simple plain SQL statement, how you write it, the same thing is happening here. But if you look at here, this grand total, right? This grand total, the initial filtering contract is not being filtered by an individual row of location in this case, right? It is not filtered by individual row location alone. The grand total is not filtered from the location, right? But it does get filtered by the slicer in this report. So it is very much important to note down that the initial filter context for this highlighted cell is only the slicer containing the month August. But if you change a different month, right? If you select different months, obviously the grand total will also get impacted, right? The measure in this case, the value of your measure will get changed based on the selection that you make it, right? So now let's have a quick quiz. So what is applied as part of the filter context? What is the answer for this?
Measure.
No. What is applied as part of the filter context? Okay, I'll just maybe it is confusing for you. I'll give you some clue. Okay, I'll just probably rephrase this question. What are the sources of filter for the filter context? See, as part of filter context, right, what are the things that you can apply? You can use rows to apply a filter context. See, in the matrix, that's what happened, right? See, in this case, it used the row as a filter context and column as a filter context. Row, column, what else? Slicers, filters, and also we can use calculate function. using which we can, so these are the sources that can be applied as part of the filter context. The next question is, what is initial filter context and what is filter context? What is the difference between these two? Whatever we did was the implicit filtering, right? Whatever we did was implicit filtering. For example, if you take here, right, we did not do any explicit filter, right? It did the filtering implicitly, implicit filter. Even in this case, right, we just selected this one, but behind the scene, along with the August month, for this row and for this column, it did the filtering, right, behind the scene, implicit filter. The initial filter context does not consider the calculate function. So it does not consider the calculate function. In the case of filter context, we use calculate function, right, to modify the filter context. We use to modify the filter context, to add a filter context, to delete a filter context. We use calculate function. Whereas in the case of initial filter context, did we use any calculate function here? Nothing, right? Okay, so that is the difference between these two, initial filter. And next one is, what is the difference between evaluation context and filter context? What is the difference between evaluation context and row context? Filter context and row context falls under evaluation context. That's all. It's one type of context. That's all. Okay, that is the difference between these two. The next one is, does evaluation context apply before the DAX formula evaluates? This is very much important. The environment, evaluation context means environment. Does environment apply the before DAX formula evaluates? If you say you don't know, that means you did not understand whatever I explained it a while back. Environment, so does environment applies before the DAX formula evaluates? What do you mean by environment? The highlighted cell is a example, right? Or the slicer, the surrounding values, environment in the sense surrounding values, right? So that's what the first it applies the filters and then only it evaluates the DAX formula. So do you remember when I explained this one? See, in this case, first it did the filtering and then only it did the aggregation. Simple example is this one, right? It did the filtering on Hyderabad city and then the filtered value got propagated from the one side to the many side of the this one relationship, and then in the sales table it filtered all the Hyderabad related records and then only it evaluated the DAX formula. Are you able to understand now? Does evaluation context apply? Yeah, based on the circumstances, based on the surroundings, right, or environment, right? Right. First, it applies the environment, right? So for this environment, for this filter context, first you do the filtering and then you do the formula evaluation. That is what it says. Is it possible to use filter context along with the row context? Can we use the filter context along with the row context? Is it possible to do that or not? You just tell me. So we know what is row context. We know what is a filter context. Can we combine these two things? Can these two coexist? That is what the question. And the next one is, how do we transition the row context to filter context? Is it possible to filter first? Okay, before we get in here, so how do we do the context transition? Is it possible to convert the row context to filter context? Is it possible? To answer to that question, I just go here and I'll show you. I just select this one. fact sales. The same formula I'm going to create a new column. So this is a row context. Any calculated column you created, it is doing the row by row calculation only, right? So what happened? New column. Okay, so now what I do is, so I told you using SumX or any iterator function, also we can define the row context. I'm going to use SumX. There is a function called SumX. So what I do is, the first argument for any iterating function. What do you mean by iterating function? The function that ends with x. So they call it as a x function. Okay, x function. So in practice, most of them they call it as a x function. The average x, sum x, min x, max x, all these functions are called, they call it as a x functions. Okay, so this is the one we did it. I just go and select this one. The SumX function takes the first argument as a table. Not only the SumX function, all the iterating function takes the first argument as a table, and then it evaluates the expression, this expression, whatever you define it here, row by row. But when you see here, it is not evaluating it row by row. It did the overall total. It computed the overall total here, right? It computed the overall total. If you add all these values, right, totals is what, if you add all these values, you will get this one. And in this case, what happens? So it does the row by row evaluation for each row, right? For each row, what happens is, it does the row by row evaluation for the entire table, and then it does the sum. Okay, that is what is happening here. It is not applying the filter context here. Is there any way I can transition this row context into filter context? Is it possible? Let us see if it is possible or not with this other calculated column. I'm going to define another calculated column. I'm going to use calculate function. With calculate function, we will see if you are able to modify the context. Sum x fact sales and sum x fact sales correct only, fact sales. Okay, let me do one thing. Sum x, and this is the one is for this one. Okay, and this one is for this. Okay, this one was for this expression and this one is for 1 second. Like there is a circular division deducted, and here sum of axes. Okay, so in this case what I am going to do is I just go and create a measure here. So with measure also you can perform row by row calculation using iterating function like sumx or minx, maxx, you can do it. I just go and click another, sorry, not this one. I'm going to select a code here, code visual. So this is sum of sales, you remember, right? I just show you this one. Total sales measure. If you see here, sum of sales amount, this is just sum of sales amount. So in this case I will use sumx function here. Instead of using sum function, I'm using sumx function here. So in this case I did the row by row evaluation, right? Row context, I define the row context as part of measure also, that is also possible. And here it should, one second. So in this case, right, okay, now the question is why it is not, sumx is not working here. So the row context, right, when you use sumx function, as part of your data view, or if you try to create a calculated column using sumx function, it is not doing the filter context. For each row, it does the row by row calculation for the entire table, and then it does the aggregation for the entire table, and then the same thing is done for each and every row. So that is the reason why it is not doing it. Okay, sumx is not required, and simply you can go for the plain this one. Okay, so this is more than sufficient, and ideally this one should also work. Okay, so instead of using a calculated column, you can use some measure also. Using in the measure I've used a sumx function. Using a sumx function also you can define the sumx function, iterating function. Using iterating function like sumx, we can define the row by row context. So now the next question is, can I combine this one, right? So the next one is it possible to use filter context along with the row context? Yes, that is also possible along with the row context. For example, if you go here, right, so you can do something like here I'm going to, this is my row context, right? So what I am going to do is I'm going to use a filter context. So what I am going to do is I'm not going to use calculate. Using sumx also you can combine the row context with the filter context. So here what I'm going to do is I'm going to use the filter function. The first argument for any iterative function is supposed to be table. Look here, the syntax, it shows clearly table, and second argument is your expression. The expression we already mentioned it. Here we are supposed to specify table, but I used a function called DAX function called filter function here. For example, I have something called fact sales and comma. The filter function returns a table. So for that reason, I'm using the filter function. For example, I'm going to use some condition, okay, for you to illustrate how to apply the filter context along with the row context. For the sales amount, so basically, right, so it's kind of a commission kind of thing, right? So total or the commission. So let's say we want to compute the commission. Let's say the salesperson, those people achieved more than 500, so they are eligible for some commission. In this case, I already have a sales amount column. You just think that way. Those people achieved more than 500 sales, they are eligible for 0.0 into 0.025, something like that, okay, some 1.5. Sorry, here fact sales, okay. So this is the commission. Look here. So both the filter context as well as the row context can coexist. So with this, you are able to understand this one as well, right? To summarize or put it in a single liner, filter context filters the data. It does not iterate. And the row context iterates the table, but it does not filter. Right? Filter context filters the data. It does not iterate. Right? And the row context iterates the table, but it does not filter. But there is an exception here. You can combine both the filter context and the row context. Okay, remember that. Next one is now you understood the idea behind the evaluation context. So evaluation context is the context, it modifies the value of the DAX expression by filtering the data model. Okay, there are two contexts as part of evaluation context. One is the row context and filter context. Both the row and filter context can coexist. Okay, and the DAX create a row context automatically whenever we define a calculated column. And also when you create a row context programmatically, you can create a row context programmatically using iterator functions like aggregate, like a average x, the sum x functions, okay. And also you can nest the row context, right? We have something called earlier function. So that is useful to get access to the previous row context. When I say row context, which means the current row. So current row, right? So in this current row, what is the the expression, right? So how what is the value for the current row? What is the value for the current row? For each and every row it iterates. Is there any way if I can get the previous row's context? So that is where we have some earlier function, which I will discuss it later. Next we will jump into understanding the simple aggregation functions like the count functions and count functions in Power BI. Okay, so one of the common tasks for the data analyst is the aggregation, performing aggregations. So what is aggregation? In simple term, summarization. For example, let's say I have a column by the name of sales. I want to sum the entire sales column in order to obtain the total sales. In that case, we use sum function, which is an aggregation function. Like sum function, count function is also one of the commonly used aggregator functions, like sum function, count function, and min function, max function. Likewise, a couple of aggregator functions are available. This is common to all the even in the SQL Server, SQL query, you can find all these aggregation functions. Even in Python, there's something called pandas package. As part of that, you can do all kind of, these kind of common aggregations. You can do it. Distinct count, count rows, all these things you can do it. So now let us take a look at the count function Power BI DAX. The count family includes almost 7 DAX functions, like count, county, these functions. Okay, so now let us take let's take a look at each and every one of these count functions. So we have something count function. It counts only the number of values in a numeric cell, but excludes the blank value. Okay, exclude. For example, I have a column called quantity. In the quantity column, how many let's say I have 10 rows are there in total. In the quantity column, I have 2 blank values are there. So overall 10 rows. Of the 10 rows, 2 rows I could see blank values for the quantity column. The remaining 8 values, right? 8 values in the quantity column, it has non-blank values. So in that kind of, in the kind of situation, if you use count function, it returns 8. It excludes the 2 blank values. So the count, you can use it for numeric values. So we have something else called count a function. It counts the number of all values in a column, including text. Okay, it counts numbers, strings, dates, boolean, but it does not count blank values. Like count function, it does not count blank values, but it, as the name suggests, a means all. Okay, you just think that way. Okay, strings, dates, boolean, for all these data types, it does the count. And next we have something called countEx function. CountEx function also counts the values in a column for a table set or filtered table. It counts numbers, strings, dates, and boolean also. It excludes blanks and boolean data. Sorry, so this one, right? It excludes, the countEx function excludes the boolean values. With the numeric or text, it will count, right? So it exclude the blanks and the boolean data. Okay. The next one is the countAX function. The countAX function, how it works is, for each row of a table, it counts the number of values that result from evaluating an expression. Whenever you see the X function, the function which ends with X, it's all iterating function. So in this case, it evaluates an expression. Okay, and the next one is the distinct count. It counts the distinct values in a column, including blank values. So count blanks, as the name suggests, it counts the number of blank values in a column. And next one is count rows. It counts the number of rows in a table. So look here, I just categorized the count family of functions into 2 buckets. One is the excluding blanks, other one is including blank. Okay, these functions will help us to it will include the blank values also. Especially the count blanks will help us to find out the total number of blank values in a column. And so in these functions, right, this count function will work only with the numeric value. Okay, now what we will do is we'll take a look at all these functions in Power BI. I already created a script for this. I just, for the time being, I'm going to close this, and because by opening multiple files, the system gets hangs. Still it is loading. Is very much helpful, okay, rather than repenting later point in time. Better you do data profiling upfront. So go to view ribbon, and then we'll do some kind of either column profiling. Okay, so it shows, but currently it is on the customer name. For the customer name column, it did the profiling, the count, number of records. How many number of records are there? 9 records are there. So here I just move this down. You see the last record, it's a null. Okay, ideally I should have removed it. Anyhow, let it be there. And the 9th record, so it shows total number of records are 9, including the blank value. And error, there are no error, and empty is 0, and distinct is 7. 3, 6, 7, 8 is there, but it shows the distinct as 7, and unique is 6, and empty string is 1. So empty string is 1, minimum is nothing, and maximum is true here. Since it's a text data type, ABC, it's a text data type, it shows minimum nothing, and maximum is true. Okay, and next we will see this one. So empty is 3, empty is 3, so we have 3 null values are there. So empty is 3, and here if I select this one more time here, see here it shows empty is 0, though we have blank value here, it shows 0. Okay, in its sold, in this case empty 3, it shows correctly null, but here it is not showing it as empty here in the customer's name column. Right? For this 9th row, it is showing nothing, right? It shows error 0, right? Empty is 3, for this empty is 3. Here the empty string, instead of saying empty 0, right? Instead of showing in the empty here 1, right? It shows empty string, the blank value, it shows that as a string. It considered the blank value as an empty string. Okay, and next one is sales. This is pretty straightforward, and active, all the things, how many null values are there. Okay, we are done with this. The reason why I came here is for you people to understand, in the case of string data type, and even the blank value is considered as an empty string, it is not considered an empty value. Okay, but here rest of them, these are the numeric value. This is a boolean data type. Look here, this cross and tick, right? This is a boolean data type. So now I just go and close it. I did not do anything here, simply I close it. Okay, so now we will jump in here, and then we will start create few measures. So what we will do is, it's always a good practice to keep all the measures in a separate table. Okay, so what I'm going to do is I'm going to click on enter data. This is the best practice in real time. This is how we do it. Okay, to create a empty table, it took this much of time. Okay, anyhow, so what I am going to do is say count measures, right? So the column name I mentioned is a count measure. So here what I do is I just go and rename it measures table. Okay, so what are the measures that I created? We'll make it part of this measure table. Okay, so that later point in time, if you want to distinguish which one is table and which one which all measures we created, if you see all the measures that you define it as part of a single table, it will be pretty simple. And even there are cases, right, within this measure table, right? So the measure table we created for the purpose of keeping all the measures under a single table. For us to refer later point in time quickly, we create this table. In some cases, what will happen is, it depends on the complexity, right? So within the measure table itself, we create some folders. Okay, some folder for KPI related measures, you keep it separately, and for other thing, right, you keep it in a separate folder. So likewise, we create folders also here. Okay, so we will see that later. And now what I'm going to do is I start create the measures here to check. Before that, I just, for our reference sake, what all the columns are there. For that, I just simply copy paste all the things here. I just take customer's name, don't summarize, so that I want to see all the values that are part of this table. So rather we can go and show as a table, we can see that, but still, right, it is good. So 2, 4, 6, 8, 9 records are there. Here we have some blank values are there. Fine. So this is the data. Instead of going to the data view, I just want to have it here so that I can refer it here itself. So what I'm going to do is I'm going to create a new measure. I just go to the modeling ribbon and click on new measure, or you can simply go here also, you can create the measure. There are two ways you can create the measure. In the last session we discussed it, but still count, I'm going to use count function. This is some name. Okay, the customer name column, I want to count it, and count.
Sir, your voice is slow.
No, I did not speak anything loudly. Okay. So am I audible now? Hello?
Yes, audible, but very.
No, yeah, I reduced my voice because I was creating this count, right? 1 second, let me just. So here what I do is count cust name. If I use, what is going to happen? Okay, the measure will get created. Look here, I just pressed enter, or you can click on this, and once you create a measure, you can click on the tick mark, or you can press enter, the measure will get created. So now what I do is, by default, right, the measure name, in this case CNT cust name, got mapped to this table, measures table. Okay, so this one is but again this one is a column name which I definitely, this is a dummy column. So what I do is I just go and hide it. It is not required. I just click on here and hide it. This is a dummy column. Okay, so when you create a table, you have to specify a column name. For that purpose, I specified the column name. Anyhow, that is not at all helpful. I just hidden this one, and the next one, this is a measure. Okay, so that later point in time, if you want to refer it, right, all the measures in a single place, you can go and check it there. So now we have created this, and I just go and use a chord visual here to check whether it is counting the number of values, total number of values that are part of my customer name table. I just drag and drop this here. So 9, the customer name is the number of values in the customer column. Okay, so 1 2 3 4 5 6 7 8 9, right? So 9, it shows 9 values here. And okay, so in this case, let me just go here and just check the customer's name column here. 2 4 6 8 9 only is there. Okay, so it's a 9, it shows a 9 here. And fine, it does the count for this one. But it was showing blank here, right? So customer's name 2 4 6 8 and ninth one, why it shows some value here? Baron it shows 3 times, and Rake it shows 1 time, and Chris it shows, and Whipple, and Whipple from where it comes. Okay, let me probably refresh this one, refresh preview. Two, 4, 6, 8, 9, and 9 is there, and where the Whipple is coming into picture, let me just the data cleaning is very much important. Even if you have a one record, which has some issue in it, I can process it and I can keep the data readily. But thing is, when will you learn, right? In real time scenario, it is not a plain vanilla. Let us clean up. Delete group. Alright, so now the sales by customer, it has one blank value here, but it shows Whipple here. Okay, let me just file and close and apply. Let me refresh it here. I'm just checking the path. Okay, so why there is a additional record is coming with it? Any problem here? So let me just check here. Sales by customer. Let us go to this folder. I thought of showing one thing here. There are occasions, though the problem looks very trivial, but it will take a hell lot of time in troubleshooting it. This is the file I'm using it. So here we don't see Whipple here, right? So but it shows something weird there. And I just look here, I just go and click OK. Maybe here I would have done something. The data view. Okay, I just sales by customer's name, here it is not there, right? So better what I do is I just remove this, or else instead of removing it I just reload it one more time. So when I refresh it, it should work. Yes, it has gone, right? So you need to refresh it, properly. Okay, good. So now if I go back here, right, so it shows 9. Okay, so 1 2 3 4 5 6 7 8 9. So guys, please remember that. Okay, there are situations, right? These kind of issues will take a lot of time for you to break your head. That is the reason why I just want to show you, all these things. When you update, sometimes you would have updated it here, and then you would have refreshed it here. Later point in time, you would have removed it, and somehow, right, the some value will get stuck up. But it is always a good practice. You refresh it first, okay? At least for learning purpose, right? You refresh it, and then you start practice it. Look here. So in this case, what is happening here? So the count cust name, and we have used the count function, right? So total number of records, how many are there? 2 4 6 8 9. All the 9 values it shows, including the blank value. So when you use a count function, it is not excluding the blank values. Fine. So I just copy paste this one. Okay, ideally it should have excluded this one. It did not exclude. I just go back here and I'll show you what is the problem here. So it should have considered as a null, right? So 2 4 6 8 9, it considered this one also, because it was not able to identify or detect this one as a blank value. So for that, what I did, I created a calculated column. In this calculated column, I just check, do we have any empty values here? How do I check empty values? Double quote. Don't leave space in between. Right, so in my project, the few guys, they did, they left some blank value, and then still, they are not able to get the, result what they wanted. Okay, so make sure that to check the blank value, you don't have to leave space between these two double quote. Make sure that you are using double quote, okay, and don't use single quote. Okay, so next one is blank. Blank is a function. Okay, blank is a function. So if it is a blank, if it is an empty string, replace it with blank. Put some blank. Blank is nothing but, it's nothing. Blank is nothing. Okay, and say you might be asking, okay, in this table here we have blank value already, so why should I go and replace blank explicitly? Because in Power BI, it considers the text value as a, even though you have a blank value, it considers the empty string. That's what we have seen it in the, as part of the profiling, isn't it, in the Power Query editor. So replace the blank value with blank function, and then, or else, okay, if this column does not have any empty string, you put the same value. Look here, Baron, Larry, everything is Chris, and here it puts some blank value here. So it is not visible to us. Now instead of using customer function, sorry, customers name column here, I just go and use customers. Customer. So now it is doing the count perfectly. So it excluded the missing value. So what the document says is the count function works for the numeric value, but the count function, right, in this case it works for numbers, dates and strings also. Okay, not only the number, it works for string also, string and date also it works, the count function. Okay, sorry, there is a confusion here. Okay, so this is the one. So with this we are able to confirm that. So the data transformation, data profiling, with this simple example you would have understood how critical this one, right? So with this column here also we have a blank value. After we replace the empty value by blank, now we are able to now we are able to detect the blank value, right? So it excluded the blank value here, right? So okay, the next one is we'll do the count function for the other things also, other columns like init sold. We'll try with init sold. Yeah, before I go there, so I just show you the count a function. Okay, count a. In this case, what I do is I just go and use the Boolean column active. Okay, so now what I am going to do is I just remove this one and I just put count a here. It was able to count the Boolean column, right? So in this case, the Boolean value stored in active column. So it excluded all the blank values. It counted the non-blank values of my non-blank Boolean values. So with this, you are able to understand the count here, how it works. Next one is we will work with count a and count x function. We'll use count x. So the count x function, I just simply you can go and click. This is another way of creating the measure. Okay. One way it is good if you create it here. Yeah, no, it's all the measures will get assigned under this table. So next one is this one, count. I want to check the count x, whether count x works with the Boolean column or not. Okay, count x. So what is the mistake here? I purposefully did this one. So what is the mistake here? Can someone tell me what is the mistake here? This is an iterating function, right? Iterator function. All the iterating functions start with the table name. So let us make our conversation bidirectional instead of unidirectional. At least you can type it in the chat window. Okay, so that let me check whether you are able to follow it or not. Okay. So all the iterating function which ends with x takes the first argument as the table name. Okay, and what I am going to do is I just remove this. Throwing error, very good, right? It's throwing error. So what did I say? Count function counts a number of cells in a column that contains numbers, date strings, not the Boolean values. Not the Boolean values. But if the Boolean values are numeric values, right, then it will work. Look here to verify this. to verify the statement which I made it, right? So calculation error in measure, the function countText cannot work with values of type boolean. So countText function counts the number of cells in a column that contain numbers, dates and strings. What does the count function does? Earlier we saw the count function. Count function count number of cells in a column that contain numbers, dates and strings. Okay, so in this case string, right? We counted the string. It was doing correctly and it excluded the blank values. CountText function also exclude the blank value, but it does not count a column which has boolean value. Okay. So this is count_a function. Count_a function. What is count_a function? Count_a function, it counts the number of values in a column that contain numbers, dates, strings and boolean values also. Okay, count_a. All, A stands for all. We just think that way. So what value, which column we used it? We used the boolean. So in this case, the count_a function counts the boolean, the column which is a boolean type, everything. So you can use it for string, dates, you can test it. Okay, but the count_a function does not count blank values. All these functions, count_a, count_x function does not include the blank values. So next one is, I just copy paste this here. CountX, right? So next we will take a look at the count_ax. Count_a and count_ax more or less same. Since the function count_ax ends with x, it is an iterating function. You can count the total number of values in a column by evaluating an expression with count_ax. That's all. In this case, what we will do is the count_ax. So since it is a iterating function, first argument is supposed to be our table. Fine. The next one is the expression. You can see, you can specify some expression. So or else we can say simply active. So the count_ax function also count the number of values in a column that contain numbers, dates, strings and boolean values also. Only the count_x function does not, count_x function and count function does not count the boolean data type. Okay, count the values in a boolean data type column. Okay, and count_ax function, you can include the expression. In this case I just simply put this one to check whether it counts the value from the boolean values also. Look here, it is counting the boolean value also. Okay, what I am going to do is I am just I'll be using some expression here, active equal to true only for the active column, right? True for those records. I'm going to filter the table based on the column active as true. Okay, active records, find out the sales by sales by customer. In this case I'm going to use okay, here I'm going to use some filter function. So now you understood what is happening here. So filter this table based on this condition. Okay, so here how many trues are there? Only 2 records. For these 2 records, and what is the total number of customers are there? So 1 2, right? 2 customers are there. So likewise you can implement some condition. The filter function, as I told you, it returns a table. Okay, so all the iterating function takes table as an argument. You need not to specify the table explicitly. Instead you can use a function which returns a table, like filter, right? You can as an argument for your iterating function. So fine, so with this, one second, let me just so now okay, so now we are seeing 3 records here. So 1 2 3 records, correct, right? 3 records, 3 true values are there, including, look here true is there, and here the text value is there, and here the the numeric values are there, numeric. But all these things where so very well, in the text data type you can specify the numeric value, you can specify these kind of values also. But end of the day, this column is a text data type, so it counts how many number of values are there in the customer name for the status active, right? So we have 3 true status, right? True, active. So that's what I mentioned here. With this you are able to understand, right? Fine. So the next one is the other functions are like distinct count. So distinct counts. So I'm going to create a new measure. Column name, that's all. It helps us to find out number of blank values that are there in your table. Now column, specific column, if you want to count the number of blank values. So for this, better we will use customer's name. Let us see what happens here. When I use this one, distinct count, sorry, this is distinct count, right? So it gives me the customer's name, distinct count, a distinct value. Oh, it counts the distinct values in a column, okay, including blanks. It counts the distinct values in a column, including blanks. So in this case, how many distinct values are there? Why it shows 7? What is distinct? Unique values. So this is a unique value. 1, 2, and 3, 4, 5, 6, and including the blank, 7. So hope you understood what is distinct, right? It counts the distinct value or the unique values in a column, including blanks. And next one is we have something else called count blanks. It counts the number of blanks in a column. If you wanted to know the blank values in a column, count blank. So if you wanted to know the blank values in a column, best thing we will use for a change, we will use sales instead of using the customer name all the time. So I just go and remove this and count blank. We'll put it here. So in the sales column, how many number of 1, 2, 3, 4, right? 4 blank values are there. To find out the total number of blank values in a column, count blank. To find out the unique values, including the blank, you can go for distinct count. And finally, count rows, number of rows in a table. Valid table. Simply you need to specify sales by customer. That's it. So in this case, I just say count rows. 9 rows are in a table, right? So here 1, 2, 3, 4, 5, 6, 7, 8, 9. So total number of rows, which includes the blank values. Here it it counts the number of blank values in a any specific column, right? So in overall, how many number of records are in a table? So and count blank counts only the blank values, distinct count unique values, the count function. So now to summarize, the count function count number of cells in a column that contain numbers, dates and strings. It does not take into account of the blank cells, okay, and boolean values also. It does not take into account of the boolean values also, the count function. The next one is the countx function. The countx function counts the number of values in a column that contains numbers, dates and strings. And in the case of count function, it counts the number of values in a column that contain numbers, dates, strings and boolean values. And count function also does not count the blank values. So the next one is count ax. Count ax function count, it is same as the count function, but only difference is you can evaluate an expression. So that is the difference between all these count family of functions. Okay, Any questions? Someone raised hand. Yeah. So Radha, yeah, go ahead. You're asking some question. Any questions?
Count and count rows. That's it, sir.
Count and
Count rows.
count rows is for total number of records in a table. That's all.
Okay.
Which includes
Okay.
blank value also.
Okay, fine. Okay.
But the count function, it counts the number of values in a column for a number data type, date data type, and string also. Okay, but it does not take into account of the blank values. Look here, that's why I have grouped the count functions here. So these functions does not include the blank values while doing the count. But as I told you, A and AX, A means all data type. You just think that all data type, okay, including the Boolean values. But whereas count X all except the the Boolean value, okay. The count and count X, yeah, count and count X, it is not taking into account of the blank values, and also it excludes the Boolean values. And count A and count X all the data types, okay. It takes into account, and this is a unique value. That's all. Clear? Is it clear? Okay. So next we'll take a look at the average functions. In average also we have something like average and average A, right? So functions are there. The average is pretty straightforward. Average is a aggregation function like count, and the count is an aggregator. Similarly, the average is also an aggregator function. So what I do is I just simply create another measure here. Here I just take average measure. So the column name, simply you specify the column name. Here the sales. Okay, instead of sales, right, I will use unit sold so that you can compare simple values. You can compare it quickly. So 8.83. So average function, right? So it excludes the blank values also here. Okay, so here 25, 37, 25, 37 plus 6 how much? 43, 53. 53 divided by 6 how much? 53 divided by 6. 8.83, right? We are getting 8.83, the average. This is a pretty straightforward function. Next one is average function. Average function takes the specified column as an argument and finds the average values in that column. Okay, so the average function supports logical values. Let's see that. Average A, as I told you, right? So A, all data types, something like that. So in this case of unit sold, so 367, right? Okay, it's not opening. It supports logical value. That is what the Microsoft document says. We'll go and check it out. .75. So in this case, average A. So I have used the active, right? So 1, 2, 3, 4. So it considers true as 1 and false as 0 here, and 1 here, right? So logical true, it counts as 1 and 0 as false as 0. Okay. And in this case, how I got, so 1, 2 and 3 plus 0 is 3 divided by 4. 3 divided by 4, how much? Let me just check here. 0.75. Got it? It's perfect. So you understood, right? All the trues will be considered as 1 and false is considered as 0, and it excludes the blank values. Okay. So that is what average is. The same thing you can try it for the non-numeric text. Okay. So the non-numeric, in the case of non-numeric text, it considers them as 0. For example, Baron is 0, 0, 0, and Chris is 0. All the non-numeric text. The numeric text, it considers a 1. Okay, numeric text, it considers 1. Empty text, it counts as 0. So the empty text, this is 0, and non-numeric text, right? So this is all non-numeric, right? It's all considered 0, 0, 0, and this is considered as 1. So you can try, for this one also. Okay. For other columns also. So what we conclude is averages support logical values. The logical value true is considered as 1, false is considered as 0, and values that contain non-numeric text count as 0. Okay. The empty text considered as a 0. And next one is average X. We have something called average X. X, the function name ends with X, hence it is an iterating function. This function takes a table as its first argument, okay, and expression as the second argument. One way it is easy to remember, when it comes to the iterating function, right? The first argument is supposed to be your table, sales by customer, and the expression. So here I say simply the same thing, right? See, the average X, like count X, right? It does not support Boolean values. Let us test it out here. Average look here. So the average X function does not support logical or Boolean values, whereas the average A function, it supports almost all the data type. Okay, like count A function. Okay, here it, in the case of average X, like count X, it does not support logical Boolean values. Okay, so when there are no rows to aggregate, it will return a blank. So if you have a rows, but none of them meets your condition. For example, you are using some filtering condition or something like that, right? then it returns 0. If any matching, if it finds any matching criteria, it does the average. If it doesn't find any matching criteria, it returns 0. Okay, and if you don't have any rows in it, right, it will return blank, and it does not do the average for boolean values. That's it. Okay, and you can try with other columns, right? You can use some kind of the expression here, and you just like how I tried for count AX, right? Same way you can try for this one also. So we have something else called moving average. Okay, moving average and rolling average. It's quite interesting. So what I will do is, it will take for some time to explain that. We will continue that one tomorrow. And already we discussed about sum and sumx function. Sum is an aggregator. Sumx is an iterating function, because the function sumx ends with x, right? So the first argument, it takes the table, and second argument is an expression. As I told you in the last session, the sumx function and sum function, in one way both of them are same. The sum function is a syntax sugar. We call it a syntax sugar to simplify the developer to write less number of arguments, specify the less number of arguments, something like in that kind of situation you can go for sum. Now the question is, okay, syntax sugar is fine. Is there any way if I can evaluate an expression based on which, if I want to do some kind of summarization, in that case of situation you can use an expression, but you cannot use an expression as part of the sum function. You need to explicitly specify sumx. If I want to do some kind of aggregation using sum function, behind the scene, the DAX engine, what it does is it translates or it converts my sum function into sumx function. That is what we discussed. Anyhow, since we are left with 2 more minutes, I will show you that one more time. This file already uploaded it, the PB, but today, since I created the proper measure table, everything, right, I'll upload this one so that you can download. I hope all of you are aware of the location, right? So in my website, instead of Power BI, you need to go to PBX. Anyhow, I'll share the link also today, don't worry. Modeling tab and go to new measure. So not only the sum function, right, we call this a syntax sugar, max function, min function, average function, all these aggregator functions, okay, are getting translated as an iterating function. So the sum function gets converted as a sumx function behind the scene. Similarly, the max function will get converted as a maxx function. Average function gets converted as an average x function behind the scene. If you want to simple aggregation based on a single column, alright, so in that case you can use the plain sum function, average function, min function, max function. Okay, if you want to do some kind of aggregation based on the expression, or by evaluating an expression, or by applying a filter, all the conditions, so in that case you'll have to use the x functions explicitly. look here, I am going to use the same thing to validate my statement. Okay, and the first argument for the X function is supposed to be table sales by customer, comma. See, I'm not using any complex expression. Simply I specify the sales column. Okay, so the sum X function sums the sales, that's all. Both of them will be same. So in the case of iterator, what happens is the sales by customer table is scanned for every row in this virtual table. So in this case, right, it considers it creates something like a virtual table. Okay, for every row in this virtual table sales by customer, this expression is evaluated. Whatever the expression that you specify, it will get evaluated. A row context is created by this iterator. So once this expression have been evaluated for each row, the rows are aggregated according to this iterator. Okay, so now we are done with this. I just go and select. So both the values are same. Sum X example, sum example. Behind the scene, the sum function gets converted as a sum X function only. Okay, so now so what is the difference between these two? The sum function always uses the storage engine for its calculations. Okay, so in this case we don't have to worry about the performance. So we discussed about storage engine, formula engine. How many of you remember? So there are two types of storage engine. One is the Vertipack storage engine, other one is direct storage engine. So if you have connected using the import mode, the Vertipack the storage engine will be used. The sum function, it uses the storage engine for any simple calculations, including the sum X function, right, like the sum of sales or any simple expression. The sum X function also, right, it uses the storage engine. But some cases the sum X function will not use the storage function. It uses the formula engine. As I told you, the formula engine, right, is not a multi-threaded one, so it will be slow. If you use anything in formula engine, right, it will be slow, and if you use storage engine, it will be faster because it processes the data asynchronously. So got it? So that is the difference between the sum and sum X function. If you want to perform, if you want to evaluate, or if you want to create any row by row context, right, so sum X. And if you want to perform any aggregation on a specific column, then you can go for some function. In behind the scene, both of them are doing the same thing. Fine. So with this, I'm going to stop. Any questions so far? I just unmute all. So tomorrow, what we are going to cover is we are going to continue with the average, moving average and rolling average, and then we will continue with the calculate function. Calculate is one of the important functions. Using calculate function, we can add a filter context, modify filter context, remove a filter context, and also we will take a look at the all functions, the all function, all selected, all except, keep filter, remove filter, all those things we'll take a look at it. With that, with some use cases, we'll take a look at it, so that you will be able to understand what situation, real times, you should be able to use it. Okay, since you don't have any questions, we'll share the video later sometime, and in the meanwhile, we'll upload this updated file into the GitHub report folder, and we'll share the link. You can download it and start practicing. All right, fine. So let's circle back same time tomorrow. All right, okay.